Let's keep trying to do the meeting. We will talk about two more useful derivatives or useful limits and then do some examples. Okay, these are just the limits. Okay, first one. The limit as x goes to 0 of the sine of x over x is equal to 1. Right. The limit as x goes to 0 of cosine of x minus 1 over x equals 0. All right, so I have examples for working with a bunch of limits, and I think we're going to skip doing the proof. So do examples for that. The limit as x goes to 0 of sine of 5x minus over 2x. Limit as x goes to 0. I'm going to bring this over as a 1/2. Sine of 5x over x and we're going to multiply by 5 over 5 to get this nice limit in the middle. Okay, let's bring out this part. This part. All right, sine of 5x over 5x. This will be 1 as x goes to 0, and you have 5/2 times 1. Next limit, we have x going to 0 of sine of 3x over sine of 7x. See, I have it split up into two limits, and then we'll talk about what's next. Limit as x goes to 0. Sine of 3x over the limit as x goes to 0. The sine of 7x. Okay, I'm going to take the numerator and divide by x, take the denominator and divide by x. then multiply this numerator by 3 over 3. No, 3 over 3, yes. Second guessing. This will multiply by 7 over 7. So I was looking for the sine of 3x over 3x, and then this is the sine of 7x over 7x. What does that leave? 3. All right, this limit will be 1 times 3 over 1. Just put 3. And this limit also goes to 1, so 1 times 7. This time, we have the limit. I used theta, so theta goes to 0 of 1 minus cosine pi theta. Divided by the sine of theta. And we'll just simplify this limit. So from the numerator, let's take out a negative sign, and we'll just write this over to the side. Oosh. That's fine. We will have, this will go with multiplying this by pi over pi. And theta over theta. Pi theta over pi theta. Oh, that's me. Let's see, I've got an alarm. All right. We need to use this 1 over sine theta and write it as, oh wait, I can take a theta, let's write this one, over here, over this part, theta over sine theta. limit as theta goes to 0, we have pi times, shift this down below this part right there, cosine of theta, pi theta minus 1. Oops, subtract 1 over pi. Cool. That will be a nice limit right there. And for this part, we'll put 1 over this, which will flip it. So 1 over sine theta over theta. I feel like it'd be nice to bring out pi and then have the limit of this part. Times, let's see, where are we at now? Actually, I just kind of rewrote this and then we talk about what the limits go to. Take it in parentheses. Okay, as theta goes to 0, this piece here goes to 0. This is 1 over 1. This part here, the denominator goes to 1. Okay. Pi times 0 times 1. Which is still 0. All right, I forgot. Oosh, way back here was a negative sign, so don't forget the negative sign all the way through the whole problem. Bring it out, just put it in here each time. And then we'd like a negative pi. Okay, so negative pi times 0 times 1. Still get 0. We'd like to skip the proof, but if you would like to see the proof for the derivative of the sine of x or cosine of x, they're in the book. You just use the definition of like the limit as h goes to 0, put in x plus h. Anyway, we're gonna skip the proof. Okay. More trig functions and their derivatives, and then practice. We'll relist sine and cosine. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of the tangent of x is secant squared of x. Okay, these ones you should probably memorize. It'll help with getting through homework quickly. It will help with your next semester. You're going to do antiderivatives, so it's good to know at least these three. We also have the derivative of the secant of x. These ones, though, I usually look in the back of the book. So for the secant of x, you get, let's see, secant x tangent x. Let's do this. The derivative of cotangent of x is negative cosecant squared of x. The derivative of cosecant of x is, let's see, negative cosecant of x times cotangent of x. Okay, so it'd be nice to memorize all of those, but for sine, cosine, and tangent, I would just start to practice right away. And let's just try looking at doing the derivative of two of the trig functions before doing practice problems. So we'll go back and work through the derivative of secant of x. All right, so I rewrote it as 1 over cosine of x. And then I used the quotient rule. So your top function is 1, and the bottom function is cosine of x. So we called the top function f. That would be g on the side. Low d high f prime g minus high derivative low, so f g prime square the bottom. Okay, the derivative of the top function would be 0. Okay. Times cosine of x, times 1 as f, and the derivative of cosine of x. And then the bottom squared. Okay. 0 plus sine of x over cosine of x times cosine of x. Let's do 1 over cosine of x times sine of x over cosine of x. we're back at cosecant of x times the tangent of x. Actually, wait, hang on. 1 over cosine is secant of x. That's better. I think we'll work through taking the derivative of tangent of x. Next. Show. Okay. So you start with rewrite. Whoa. Rewrite tangent as sine over cosine. We like to call the top function f, and this will be called g, and use the quotient rule. So put that on like the side. F prime g minus g prime f divided by g squared. Let's work on the numerator. F prime would be cosine of x times the bottom function, which is cosine of x. Subtract. G prime times f. So we'll take the derivative of cosine, get negative sine of x times sine of x. And you've got the denominator squared, so a cosine of x squared. We have cosine squared of x plus sine squared of x, which hopefully you remember as an identity. Okay, where are we? Cosine squared. Cosine. So just wrote the power in here. Either way, means the same thing. Okay, the numerator would be positive 1. So now we're at 1 over cosine would be secant, and it was secant squared of x. Cool. That's all I want to do for the like basic trig identities. Let's start doing some other examples. Like finding derivatives for some function f. We're going to let f be e to the x over sine of x. Right, I know our function is called f, but just as a habit, we do like to call this little function in the numerator f, and then this will be called g. So I am going to stick with all of the letters for good practice, but it might be, well, we can change it up a bit. We can call this h, as long as we use the right formula. So we can call this h if we want to. It's okay if you call it f, as long as you know what's going on. Okay. The bottom function times the derivative of the top function. Subtract. Top function times derivative of the bottom function. Divide by the bottom function squared. Okay, f prime of x, the derivative of f with respect to x, will be sine of x times e to the x. Top function is e to the x. Derivative of the sine of x will be cosine of x over cosine of x squared. Nothing amazing, but we could factor out e to the x for fun and have a sine x minus cosine x over cosine squared of x. Okay. Next function, let's just call it something new. We'll call this h of x. Be the function x squared times tangent of x. This x squared we'll call the function f. This function will be g. And use the product rule. Okay. H prime of x is f prime g add g prime f. So the derivative of h of x will be f prime, so 2x times tangent x. Let's add, oh, we can put it on. I think it could fit. G prime, so the derivative of tangent of x is secant squared of x. Multiply with that first function, x squared. I factored out an x, and it leaves 2 tangent of x. Add x times secant squared of x. Ouch. I think we want want to call the next function something different, like g of x. Okay, another one, example. G of x. Be x times sine of x. Okay, that's all. Yeah, it's fine. Find the slope of the tangent line to g of x at x equals pi over 2. All right, slope of the tangent line would be g prime of x, and then we're just looking at x equals pi over 2. I want to just do the derivative, and then we'll put in x after. So g prime of x with this as our function f. And I think it would be best to call this something else, like h. We're using the product rule, so f prime h plus h prime f. Okay, derivative of x will be 1. Add h prime, so derivative of sine will be cosine, and then times that x. All right, so the sine of x plus x times cosine of x. And then find g prime of this number. All right, input pi over 2 for x to this function here. To get sine of pi over 2, let's see. Add pi over 2 times cosine pi over 2. Sine of pi over 2 would be, well, let's draw a little bit. Going over 0, 1. 1 for the sine, 0 for cosine. This is going to be 1. This is going to be 0. Let's get 1. That's my slope. Another example, and then something new. Let's go up here. We'll call the function v of x, and it equals tangent of x times the sine of x. and find the derivative. We will have the product of two functions, so the product rule. Let's call the first function, which is tangent x, label it f. This is my g. F prime g and g prime f. F prime. Derivative of tangent of x will be secant squared of x. Times g, the sine of x. Let's add g prime. Derivative of sine is cosine. Times the first function, tangent. I think it can be written better, like simplified with trig identities, but we'll just leave it there for now. All right, I think moving on to higher order derivatives. So we take a derivative of a derivative. You can keep on taking derivatives. So labeling that. Okay, so you start with a function. I probably should say that f is a differentiable function since we're taking the derivative. But I'm just jumping into the first derivative. So first time is derivative with respect to x of f of x equals we'll do it like this, f prime x. All right. The derivative with respect to x, so the second time, of f prime of x, we call f double prime. So f double prime of x. Now I talk about f triple prime. Will be the derivative of f double prime. So third time, take the derivative with respect to x of f double prime of x. And that will be f triple prime. All right, past this point, we start to put a number in parentheses. So f to the fourth of x is the derivative of f triple prime. So here, fourth time. I'm going to flip it around. We're going to go on. Actually, we don't want to do 4 slashes. You can do 4 slashes if you want to, but I think at that point, we'll go here. Okay, derivative with respect to x of f triple prime of x. And then so on. Let's do the next one. So the fifth time. I like it this way now. So we'll do f to the fifth of x. So this is written as the fifth derivative, and it will be the derivative with respect to x. 4 derivatives for that function, and then you keep on going. All right, let's try some examples. We've got f of x add sine of x. F prime of x. Derivative of sine is cosine. F double prime of x. So second derivative of f with respect to x. Let's take the derivative of f prime of x. Derivative of cosine is negative sine. Let's do f triple prime of x. So take the derivative of this function. Derivative of sine is cosine, and then don't forget the minus. I did one more, so we're going to do the f to the fourth of x. 4 derivatives. So take the derivative of that function. Cosine will be negative sine, so negative sine. You have your function, 1 derivative, 2 derivatives, 3 derivatives, 4 derivatives. You can keep on going. But let's do this one. Okay, f of x equals, let's peek, 7x cubed minus 2x plus 10. We're just going to do derivatives on the side. First one is 21x squared plus 2 plus 0. Next derivative, f double prime. F double prime. So go back here, and the derivative will be 42x plus 0. Next one, f triple prime. We're going to have a 42 once you take that derivative. F to the power 4 of x in parentheses. So it's the derivative, 4 derivatives of that function. So derivative of a number equals 0. And then if you do the derivative again, you'll have 0, and again, you'll have 0, because it's still a number each time. So you could say, that was 4. Looks the same. Oh no. I'm gonna go check on the cat. One moment. All right, there's just a little bit more to talk about. Yeah, just a tiny last final note. We've actually, I think, talked about this before, but just a reminder about the position function, the velocity function, and acceleration function. Okay. Given a position function, which is usually called S of t, where t is units of time. Given a position, we have a velocity function v of t equal to s prime of t. So S of t will be some function, and it gives you position for an object. Okay, S prime of t, we call v of t. That's your velocity function. Okay, the last part is S double prime of t, we call the acceleration function a of t. E-L-E-R A-T-I-O-N function. Oh, I forgot to put units. I would put the units. So let's say that this is in feet as an example, or actually up here in feet. This would be something like feet per second. As like an example for units, this would be feet per second squared. That's all I wanted to do today. So that's it for the meeting. No office hour today, but we'll meet tomorrow, and I'll do an office hour tomorrow. Again, I'm going to work on catching up on grading, and